First of all, I'll explain who I am. My name's Michael Canellis. I have a few different jobs at OSIsoft. I run communications. I also have the title of IoT analyst because I worked as a journalist and part-time as an analyst for a number of years. And I'm also in the marketing department. And our panel today is called AI and ML, the Pitfalls and the Promise. It's a sort of, it's an alphabet soup of letters we see all the time. Everyone's talking about it, but where's it going? I had an interesting experience last week at HMI. I was speaking to someone at IHS named Alex West, and he recently just came from a packaging conference, and he asked an audience pretty much like this one. He said, okay, who has add-on services using machine learning or advanced intelligence so when they sell a product, they can actually monitor it in real time and predictive maintenance and things like that? And every hand shot up. Then he said, how many of you actually have paying customers for that? And he said literally every hand went down. He didn't know whether to laugh or cry. But it gave, it was kind of an eye-opening sense of, what this industry's like. That the technology's there, the willingness is there, but the commercial ramp up, it takes a little while, but it might be going faster than that. I don't know if it's a perfect example, but it was a telling one. But anyways, enough about me. I'll introduce you to the panelists. We'll have a few questions. If you have questions, I know you've been sitting there all day, learning a lot. Please, at any time, raise that hand and ask away. We'll definitely try to address that. Maria will be running with a microphone, and I just love to make it as interactive as possible. So first off, to my immediate right here is Humera Malik. She's the CEO of Canvas Analytics. There's actually two S's. It's two S's. I apologize for the typo there. And it's AI company, software. And someone told me to say two words to you, spaghetti and steel. So maybe you can explain what Canvas does and then also what you have to do with noodles and steel.
Okay. We'd be happy to.
Yeah,
Okay. So Humera Malik from Canvas Analytics. We are an advanced analytics platform. And as you said, it's all built on using AI, both machine learning and artificial intelligence. It's such buzzwords to say, but really, as we talk more about this, it's really making the application of AI usable with industrial data and allowing actually the operators on the shop floor to be able to use AI to empower them. So it's basically embedding AI into a software so that the industrial operators can start to use them without having a team of data scientists hovering over them all the time, and allowing them to actually scale it into multiple operations.
Excellent. Now, what are you doing in the spaghetti business?
We like the spaghetti business. Who doesn't? So we're in the steel and the spaghetti plants today. So when you talk about actually real application of AI, these are in production environments where we're using AI not just to predict and forecast some of the processes and the outcome and the yield, but actually these are fully automated processes that are being used. We have fully automated 2 pasta lines with one of our customers in their pasta production process. So we're not just forecasting what the quality of the pasta is that they're producing, but these are fully automated lines actually that are using AI without any human intervention during the process. So to keep the optimal quality of the pasta that's being produced. Same thing on the steel side actually. So it's a steel production facility. We're being deployed in about 9 to 10 of the places of the operations. Out of them, one of them actually has been fully automated using AI agents.
Oh, fascinating. That's fantastic. And next down the line here, we'll pass the microphone. We have Martin Davis at a company. I will not even attempt to pronounce the name of your company, but it's a new company. You've actually, because you've been at Pi World before, speaking as the CIO of JD Irving.
Yeah, I've been around the Pi world for probably 7 or 8 years, and was aware of it for a while before that. So I've been driving what I would refer to as kind of Industry 4.0 operational intelligence for a number of years. And so my presence here has been a regular thing. More recently, I've gone out on my own, started my own company, Denelm Associates. And we're looking at driving more of a strategic level view of how do we utilize some of these things. So how does tools like AI and ML really start to take us to the next level? But how does that form part of a bigger picture? How is that part of the strategy that moves the business forward? So that's kind of a little bit about me and the background.
And at the end here, we have Patrick Fetterman at LNS Global, or LNS Research as it formerly was known. Give us a quick thumbnail of what you do, and then I have a question for you as well.
Thanks, Michael. Again, Patrick Fetterman. LNS Research is an industry analyst firm that focuses primarily on industrial transformation. So we keep track of the technology companies, the providers, and their new products, analyze them as they come to market. But we also work with end users on their industrial transformation projects. We survey hundreds of companies every year around what's working and what's not, identify best practices in these projects, and use that to inform other end users on their journey towards industrial transformation. My own focus is industrial analytics and all the data models and other technology that support analytics.
You know, one thing that came up, I was speaking to one of your colleagues recently, last week in fact, Matt Littlefield, and we were talking about these stats that we see that 65% of big data initiatives will fail, or 80% of IoT initiatives have failed. And I've always been a little skeptical of that. And then the LNS view is that that's actually complete garbage, right?
That's absolutely right. That may have been true 3 or 4 years ago. It is absolutely not true today. We just completed a new survey of almost 400 users, asking them very specifically about what stage they're in the deployment of these technologies and how far along they are in their industrial transformation journey. And less than 10% reported that they were stuck in any form. Most of them were 2+ years into their journeys, into this transformation. Most of them were already seeing, more than half were already seeing payback on their investments, which is a pretty phenomenal number.
That is pretty good. Humera, Martin, what is your view on this? Okay, we'll do it that way.
I think I would agree with Patrick. In most of the cases where we have gone and seen the real deployment of applying machine learning or AI, you cannot look at ROI overnight. It's not possible. But in a short to long term, actually, you start to see the benefits. And you have to start looking at it, the operational benefits as well as the financial benefits. You have to start getting operational benefits that start then contributing into the financial gains. It doesn't necessarily all happen at the same time. One of the challenges that I would say from gaining benefits you have to be aware of is sometimes it's very hard to isolate it. These are very complex environments where we go in and function. It's very hard sometimes to just isolate and say, because you impacted this. So that's why you have to look at the overall operational gains and then assess the financial benefits related to it.
Are they often, do plant owners, are they skeptical sometimes saying, well, that actually didn't occur because of your analytics? That was going to happen anyway.
We haven't seen too much of that. I would say just there's hesitancy to share sometimes. And that's just got to do with how the businesses are structured today and how they want to deal with the vendors. But I think it's more obvious if you can lay out some of those operational gains up front is what really is the outcome that you're looking to gain. And then you need to be you need to actually define how you're going to measure those outcomes. Because if you can't measure them, then you can actually get into those ambiguous situations. So we learned in the early phases when we were actually doing early trials is that we need to be clear up front about what those outcomes could be and how do you measure them. Because if you can't measure them, then we would be held accountable for it at the end of the day, or we won't, basically, because even if the impact you can't measure, then there is no point.
That's intriguing, because one question we get quite a bit is, how can I justify this project to my boss, right? Things like, and so you're talking about having measured outcomes in the beginning of the project. Was that from experience? Like, actually, 2-3 times you go, okay, predictive maintenance, we can expect a 10% gain. Let's go for that. And that's, at least it's provable, and everyone around the table will at least be able to understand it. How do you know a benchmark to use?
So there's a way that we have now figured out how to do it. The way we have done it is when you go in first, don't immediately go in and go for the outcome. You first have to do is working with actually the operators and the process engineers, understand what that outcome is and how do they measure today. But also understand, do they understand the impact of everything that's going on that outcome? Because there are hundreds and hundreds of parameters that they're looking at. Do they understand the impact of those? So the first module they implement that we provide is the operational insights that allows them to validate. And you have to gain that confidence of validation with them. Then they say, oh, I wasn't thinking that angle of shoot impacted my production this much. When they start to actually get that validation in their minds, then they're ready to actually start opening up about, how they can actually measure some of those outcomes. So you have to actually go in first with that mindset to actually get some validation and confidence that, yes, this actually can impact my business. And from there, then you start to show some of the outcomes that are impacted. Then they start opening up about actually, a lot of the things, how AI is now impacting their business.
Interesting. Yeah, Martin, how do you
I think there's a lot of good points been made there, and I think you have to start with what the outcome is. What outcome do you actually want from this? And you can't start from your boss has said, "Oh, that looks pretty cool. Should we go and do some of that?" What are you trying to achieve? It has to be the start point, and then you have to kind of look at what data do you have available, and do you have sufficient data available? And then if it's something that let's take the maintenance example. You've got to train the algorithms to understand what failure looks like. So have you got good data around failure? And all of those things take a lot of time. And the other aspect as well is, have you got the right algorithms to actually get the right results? And I've heard of companies that you could class it as failure, as we were saying earlier, that they're on their third company doing machine learning for them, not because the companies, the first two companies have failed as such, but the algorithms they had weren't producing the results the company wanted. So sometimes, have you got access to the right algorithm? So all of those different aspects impact whether you get the right result. So I think there's a number of different factors there. And you spend kind of what I think we were chatting earlier, we all kind of agreed, you spend like 2/3 of your time trying to sort out your data of any project. Something like 2/3?
Yeah, I think that number is maybe underestimated. It can be much higher than that. It's a little like painting a room, right? You spend all your time sanding, taping off the edges, all the rest, hours and hours until you finally go to paint and you get the final result you want. But it's the prep work makes it happen in the end, right? We spend a lot of time asking people about use cases and what they're hoping to get out of analytics or AI. And the number one use case every time we ask is predictive maintenance, partially because it's low-hanging fruit, partially because it's been adopted more quickly in the process industries where those assets are very expensive and uptime is everything. But we are starting to see, especially around AI, more creative uses of the technology and asking bigger questions. Like
how so?
Things like, how do I identify the bottlenecks in my plant, right? How do I increase sales? Some very fundamental questions that you may not be able to get to with a standard analytics package, but with a more intelligent system that handles an incredibly complex set of variables, you can start running those thousands, sometimes millions of scenarios that get you to the end result of these more complex challenges.
No, I think you're spot on. But maybe one thing we should clarify. You kind of interchangeably used artificial intelligence and machine learning. Are we really doing artificial intelligence? I think mostly what we're doing these days is machine learning. I'm not sure we've really got to artificial intelligence. And maybe, I'll pass it your way.
This is why when you were talking about having enough failure data is required. Machine learning learns from what it has seen. Artificial intelligence is really the brain functioning and making decisions on the basis of what it sees and identifies that, is this right or is this wrong? So if we get into the depth of it, really look at how reinforcement learning is now coming about. So now that we've implemented it in certain places, we're really seeing that there are places where it makes sense to apply artificial intelligence, and there are places where we have actually seen in certain industries, especially in automotive, where there are lots of repeated functions. So this is an industry that's just getting into this whole, well, they're very, very well versed on the autonomous side when it comes to actually getting the vehicles out, but at the back end in the production line, not so much. Just data collection is fairly new to them. In certain places in the automotive industry, lots of repetitive functions are happening. That's really where it's a true application of machine learning that you can apply, because it's repetitive functions. Somebody's there doing manual inspection of quality of parts that are being produced. There's still a lot of manual work that's being done. That's really where you can apply machine learning to it. You can apply machine learning in all cases of predictive failure. As long as you have failure data, you can actually train the models and you can implement predictive failure models there. But in cases of process optimization or any kind of optimization where you're looking at, like we work a lot more on the yield optimization side, that's really where the application of artificial intelligence comes in, because it's very dynamic.
But that also raises one issue that comes up, or at least it comes up in my mind. I don't know if that says much, but where machine learning actually is going to be 80 to 85% of the solution, because most of the situations are repetitive functions. How do you make that more, improve that? AI is almost reserved for those high impact but fewer in number initiatives. You know, for instance, the equivalent in healthcare might be ML is used for something a doctor would do. AI is actually used to design new drugs and things like that. Am I right, or am I totally whacked out?
We say that because that's what we see today and what
Okay.
we know. Healthcare industry actually is a perfect example of AI, because what the surgeons could do, and I was just watching this video the other day, and they were talking about removing the clot from the vessel. And what happens in that is the surgeon only knows what they are doing, but artificial intelligence enables them to actually do more than what they have been doing. It actually shows them different paths and different ways of actually extracting the clot. And it makes it better. They do it by practice. So surgeons are like machine learning, applying machine learning. But when you actually want to actually find different ways, that's when you start to apply artificial intelligence to it. Same thing with the going into plant operations. We have found that there are places, as I said, and there are several examples of it. We went into the steel plant, we went into the food plant, we've gone into pulp and paper industry, and we have identified there are complex processes where nobody really has definitive learnings, but there is experience. That experience needs to be institutionalized into knowledge. That's really where AI comes in. And it starts to actually start off with, maybe it won't start off at a very high-performing model, but it would start you off and baseline, and from there you can actually apply models that continue to learn from it.
Okay, so it's really more decision theory and decision helping and things like that
Correct.
versus, improving rote tasks.
Correct.
Okay, interesting. Patrick, I agree with you. I mean, there's decision tree. It starts out with I've heard it said as, save money, make money, and stay out of jail. So it's like you start with predictive maintenance, reducing your energy, try to increase productivity, and then move on to those regulatory issues and things like that, right? If you can just, because the order, the biggest payoffs first, and the more nebulous one, but the more valuable one, comes later.
Is that the Canel's hierarchy
It is,
of
exactly.
needs,
The emphasis
right?
on stay out of jail, right? Exactly. It's, always the wish. Any questions? Okay, we'll keep going. Oh, wait, sorry.
Sorry. Yes, I'm Josh Duncan from CF Industries. I guess I just wanted to clarify or get some clarity. Whenever you were talking about the difference between ML and AI, I guess your AI examples are you only, I guess to you, is that just deep learning? Is that just neural networks, or are you speaking to something different?
It could be either one. It doesn't matter what is the embedded technology. In some cases, it's actually neural networks. It could be deep learning. There are several other newest technologies. So we work closely with Google. So there are several methods that you can use. But it's really saying in broad, if you were to put definitions around it, artificial intelligence really is allowing you to go out and implement a technology that can learn from the existing environment but help you make better decisions. So that's what it's doing in that case. It's actually enhancing the capabilities that already exist, and it's taking it and optimizing it to a newer level.
Okay. Thank you.
How do you two define ML and AI? Because I like your definition, but it is slightly different than some of the other ones I've heard.
I think I don't disagree with what Humera said. The machine learning is definitely how can you actually teach it what's good and what's bad, and then let it figure it out from there. Yeah, predictive maintenance is probably the best example. On the artificial intelligence side of things, if you're, and I think we talked a bit about optimizing production, speed of production, things like that. The other side of that may be quality as well. So how do you optimize quality? That's another example of a similar type of thing where you've got maybe thousands of different variables, and how do those different variables in different combinations, those different inputs, it could be atmospheric pressure, it could be temperature, it could be moisture, whatever it might be. How do all of those things play together into actually producing the highest level of production at the best quality? And some of those different, the type of puzzle that you as a human being could not figure out. and how does the actual machine best help you do that? And I think that's probably, in the kind of context we're talking here, that's probably one of the bigger ones.
Yeah, I'm not a data scientist by background, right? I think of it more from the use case point of view. And when I look at machine learning, I see it, and we've seen it in our studies, used more often in those highly repetitive circumstances where you're running a process, you're making a part thousands and thousands and thousands of times, and the technology then can run that virtually and look for variations across a very specific set of variables, right? And that's where machine learning is best applied. Where AI is another level of complexity. So instead of running virtual experiments across 4 or 5 or 6 variables, you're running it across dozens or hundreds of variables. And that's not a data scientist or a computer scientist definition of it, but it is the 2 different types of applications that we hear people talking about, the 2 uses of.
And there's also just the simple data prep one. As part of my job, once I looked through a bunch of our case studies to see on the predictive maintenance, how do they do it? And the vast majority were actually just the serving up the data, and people are serving up as a symptom, almost as a trend line. And actually immediately someone could recognize right away, say, okay, that's probably the problem. So they never really fully maybe identified the cause, but they knew how to fix it. And they actually just, it was almost like OI, lack of intelligence, right? Or, lack of machine intelligence. It was just, you just give them the data, they figured it out, and on their way. And then they used algorithms for more complex problems.
Let's be clear of this. When we talk in the maintenance example, we talked about the different, the discussion earlier about the kind of progression through the maturity of different maintenance side of things. Predictive maintenance has been around a hell of a lot longer than machine learning and artificial intelligence. And a simple pi event frame could be predictive maintenance. It's triggering an event based on a variable or a couple of variables coming from the machine. That's predictive maintenance. It doesn't need machine learning to be predictive maintenance.
Another one, too, is it comes up a lot, is the people question, right? You always hear people say, oh, it's people, process, and technology, and people are the hardest part. And do people resist these kind of changes in technologies, and why? Or are they generally saying, look, this will help me do my job better? Or are they more skeptical?
I don't think that people are convinced day one. You can find management that might be convinced that we need to actually go and look for competitive advantages, and they see applying some, coolest technologies like AI for that. I don't think the operators are necessarily convinced. So you have to actually build that confidence level. And that's why when I was talking about earlier is actually if you can start using AI in simple ways that starts validating some of their assumptions, it's a good way to actually gain some of the confidence. And then from there on, you can actually start to see that then they start to come up with ideas as now how I can start using AI around my operations in several ways. So you have to start gaining that confidence before you can start to leapfrog towards getting to better results from it.
But does it find where they don't bake it into the process? These initiatives can fade away, or?
In certain places, it depends how progressive the organization is in their digitization journey. In certain places in the early stages, I think you have to do a lot of upfront legwork to gain that confidence. In certain places where they have actually gone through some of these digitization initiatives, you don't. It's more related why people are resistant to it is, first of all, it's going to create more work for me. I've got another project on my list now to do. That's how people look at these things. It's another project that's been added to my list. It's another thing I got to do, and then I don't know what benefits I'm going to gain. So you have to actually get the buy-in from those people instead of always just going from top down because somebody has got an AI project in mind. So actually go in. Use case is very, very important. You have to be able to identify, let's start small, let's find a place where it's applicable, and then do all the due diligence around it, the data quality, the quantity, the integrity, everything you have to actually validate before you jump into this project. So there is obviously some of that work, and you have to get a buy-in from these people. But you also have to be upfront in certain cases. If the eventual goal is going towards automation, then what is the path for the workforces? How do they become part of that automation? That's a journey that needs to be defined as well. Much longer discussion about how actually you can enable the digital workforce to work with AI or other technologies, but it does create fear, and I've seen it.
Because they do feel like they will be displaced, yeah.
I think you have to look at the whole change management side of things. You have to look at, and Patrick heard me say this, some of this earlier actually, which is, what's all this about? What's it going to impact on me as a person? Yeah, and one of the standard phrases you hear in change management, what's in it for me? So you have to do a couple of things. You have to, one, demystify it. It cannot just be a black box that sits there and data in, spews out an answer at the other end, because they'll reject it immediately, especially those that are maybe have owned that piece of process forever. Yeah, they say, well, you're not just replacing some of what I do with this black box. So you need to help them understand what it is. And you need to help them understand what's in it for me. Yeah, what do they get out of it? How are they going to benefit from doing this? And it's so critical to this. And it doesn't matter whether you're talking artificial intelligence or some other change. It's what do they get out of it? And by getting really into that, you start to get the adoption. Because it's all well and fine somebody up high saying, go do this. But the moment they say, they stop saying, go do this, things will just start reverting back. But if they've adopted it, they understand it, and they've started embedding it, and that's their normal way of doing things, then you perpetuate the change and you really start to get the benefits. It's not a case of the moment management loses focus on it, the thing disappears.
Almost making an extension of their arms and legs and their own capabilities at the moment.
Yeah. And there's numerous examples, both within the AI, ML world and elsewhere. And you can't afford it to be a black box. You can't afford for the people who are actually going to be using it and benefiting from it, for them not to understand how they're benefiting.
Yeah. And then show them examples. Patrick?
I agree with both of these. Excellent points there, Martin, especially. One thing we are seeing that's indicative of a higher level of maturity in the market as people look at technologies like AI is that they're moving beyond the kind of fundamental questions of what is it, right? How I'm a little nervous about this stuff. They're realizing it's not magic, right? Even though people were kind of sold it as magic a few years ago, where you just throw all your data in a data lake, point an AI engine at it, and magical things are going to happen. Oof. People seem to be beyond that now. And we're starting to see a higher level of maturity in the types of questions they're asking about the commercial models and about licensing and things like who owns the rights or who owns the data to begin with, who owns the algorithms after they've been trained on my data. Do you have the rights to go do that with one of my competitors, to use it again to improve their business? And so we've progressed beyond the kind of fundamental questions about what it is, right? And that's the scariest point for most companies, into real business issues that it's a good sign for the industry overall, I think.
Questions? Yes.
Brad Wilson, AGC Glass. So what is the confidence level that machine learning would always get the question correct? It's based off of data, and you could eventually get something wrong, and that loses a lot of confidence with an operator immediately.
Can I give you a flippant answer? Then I'll let the others. My flippant answer is, what's the confidence that you're going to get the question right? Seriously, though.
Yeah, we work as a team and we brainstorm about it and involve the operators, but with machine learning, it's sort of doing its own thing, and it just spits out an answer.
But most of these things are only as good as the way you ask the question, how you ask the question, the data you feed in. So that was my answer. Seemed a bit flippant, but it's based on some of those things. So it's only as good as how you set it up.
Well, I totally agree, Martin. I was going to ask the same, and I've asked most of the people the same question when they ask about why do you think ML is going to be a better decision for us? Well, the question is, how are you always sure that this is a better decision for what you're doing? So I think you have to go out and compare both, sometimes in controlled environments. So when we actually go out and implement AI agents and especially build automation, it's actually against what the human potentially is going to do versus what AI is going to do. And you do that control testing to actually gain that confidence. You don't necessarily go out and say, okay, from today, I'm just going to flip the switch and give it all to machine learning and AI to do this for me. You actually do some control testing, and you do control testing and you compare, and that's how you gain the confidence. And it's not an answer for all of the problems or the issues. It's actually an answer for some of them, where you have complex scenarios, you have actually lots of data, and you have to make decisions at every point. That's really where it's reliable right now. In the future, it might start to do more, but at this point, really, AI and machine learning is meant for lots of data, dynamic environments, and you have different frequencies of data coming at you, and you have to actually make certain decisions.
Quick question for Patrick. Were you saying that organizations are now moving from looking for education on what is ML to coming to you with defined use cases as to what ML should be doing for their organization?
That's exactly right. We are getting more and more questions, not just about the technology anymore, but about how it can be used. And again, the fundamental business questions about what should a contract for an AI system look like, right? And that's a very different place than we were even just a year or two ago.
Thank you.
I'm wondering on the business model side of the question. Right now, primarily AI ML is mostly a cloud service. You go out, you subscribe, you get it, you become a continued subscriber. Are we seeing new types of businesses emerging? I mean, some people I've talked to have talked about industry clouds or like data marts, where people anonymize and pool their data, and they might own a section of that data mart or just buy portions of data to train their own algorithms. I don't know how realistic that is. Enrique is actually, once he was talking about an idea that the next wave of companies could be people who develop software to minimize your AWS footprint. Right, exactly, because you know you're going to be using that cloud space, but you want to keep off as much as possible. I mean, are we going to see these sort of, do you see any glimmers of new types of companies like this? Or
I think we're seeing some companies specializing a little bit. So rather than being, in the very early days, you were seeing more generalist AI ML. You're now seeing companies focusing on a particular area of speciality. So you're seeing some of that start to happen.
Okay, like mining or things like that.
So they understand the subject matter a little bit more, the context of the data. Because one thing we've seen in some companies is because there's such a demand for data scientists, and they're hiring new kids out of college who maybe don't have some of the business experience, the industry experience and things like that. So they can waste thousands of hours churning on false positives in this that have no relevance at all, and anybody who's had a little bit more experience would just dismiss. So I think what you're seeing is some more specialization, more understanding of particular subject matter, and so some of that. And so you're seeing a bit of that developing. I don't know what else. If you guys want to.
Yeah, we are seeing some new startups coming out, but on kind of on the back end, on the data side rather than on the AI business side.
Like
right?
the data prep side, you mean? Or?
Yeah, so there's one company in particular that's still in stealth mode, but they're talking a lot about data conditioning and data contextualization as a standalone service instead of embedding it into something else, right? And it is in most analytics platforms. It's in many of the IIoT platforms as well.
So it would almost be a layer between something like the Pi, so data management and
That's exactly
analytics.
right. So it would be something that happens independent of an application on an enterprise basis, right? We don't know if that's going to be successful or not, but it's an interesting idea. And people, as they recognize the impact of the quality of their data and the context of their data, the impact that has on machine learning and AI and just in analytics in general, we're seeing more and more business ideas emerge on that side of it.
Actually, it's funny. Element Analytics used to be Element Analytics. Now it's Element. They moved from doing analytics and data conditioning and modeling to almost exclusively modeling. Humera, do you see the models changing or new types of businesses emerging?
I'm actually glad to see people get out of the bits and the bytes of measuring and, I'm going to charge you by the data points that you give me. Because everybody's now trying to grasp the data side. Everybody wants as much data as possible. There's certainly different, from a uniqueness, there are some unique ones, like almost setting up marketplaces for these models, and then you can actually tap into these models. That's the new one, which is coming out.
Is that viable, though? I hear that a lot. So.
I personally don't see the viability of it, because the data that we deal with, it's very sensitive data. Sometimes it's the recipe of making a something, or most of the time actually. So it's very sensitive data, and there needs to be sensitivity around the business models that need to be built around it. And then there needs to be an openness at this point about how you access that data, that you don't convert it into bits and bytes, so people are hesitant to share that data with you as well. Because we already have challenges which are, it's confidential data that sometimes can't even leave the premises. Regulatory challenges around some of the, especially on the power generation side as well.
Can be somewhat singular too.
So looking at all of that, I think there needs to be simple business models. So obviously cloud subscription-based models, they could be like we do it on a process basis or a plant basis, or you go into multi-facilities, then you actually do it on an enterprise EA agreement basis. It needs to be simplified. But the new ones that I'm seeing, I'm not so bought into the whole marketplace.
Yeah, interesting. Yeah. Yes.
Bart Roselle, Consolidated Container Company. Are you seeing ML applications where people are reducing the manual quality checks that are required for production output to reduce that or improve output?
I can give you a couple of examples. So in certain cases where they would do checks certain times, so they would only know when they would actually do the lab test. They would go out and do it, and that's when they would find out what has happened in the process. You can actually start applying some predictive models to know before that happens, so that you're just not doing diagnostics to it. That's what we do during certain processes, during the production processes, is actually predict that so that you don't have to go out and do it manually, but you're actually finding out. And then you have to determine what is the right time frame for it, so I can go make about what changes can I make to the process. Because if you're just doing it just for the hell of it, that doesn't make sense. But it has to be timed accordingly. If I do it 20 minutes in advance, I can go change these parameters and it would impact it this way. So it has to be timed in the right manner. But yes, we are certainly seeing more and more of that.
Thank you.
Yeah, I'd say that's the number 2 use case we see, and that's pretty fast emerging. So you can think of it as kind of predictive quality instead of predictive maintenance. And especially on the discrete side, we are seeing that people looking for those correlations between asset performance and quality output, right? And we're starting to see that happen more and more and more now.
Let me ask that kind of, or turn that around the other way slightly, and maybe ask you to clarify. How different is this from doing like statistical process control, giving the operators SPC screens? So, yeah, is this really that different?
In outcome, probably not. It's not that different. It's just a different emphasis on the root cause analysis and getting to it before the, one pulley in a machine really goes off. It is maintenance still, so you're doing maintenance on the machine or an adjustment on a machine, but it is in effect the same outcomes that SPC might be giving them.
Yeah, and I was thinking on the SPC, not necessarily about maintenance, but for example, on quality of a product, which you see obviously a lot more on the process side of things, where the operator keeping it within the limits, will impact the quality of the output and first time saleable and those types of metrics.
Yeah, no, that's exactly right. It's analytics being used for the exact same purpose. Yeah.
Kevin McDonough from JD Irving Limited. So over the last 7 years, we've implemented advanced controls. It sounds very similar to machine learning. We've taken all the data. We've got control loops that take it back, and we've taken the operators right out of the process altogether, and everything stays in control, and there's a great ROI. So what's the difference? Is advanced controls different from machine learning?
No, I don't think that it would be different. What you would be doing is, depending on all of the data that you've captured, if there are still some external variables that can start to impact the process or the asset that you're not necessarily getting through from the controls or from other places. So sometimes it's environmental factors. Sometimes there are other factors as well that you can start to account for. So it almost is looking at a 360 view instead of the one-dimensional view that you have from one data source or a couple of data sources. It just goes beyond that. That's when you start applying. But if you are able to monitor it as efficiently as you need to, as you think you need to, then there's not necessarily, not every case is meant for machine learning. But if something goes beyond that, where you're looking at more data input that you're not getting through it, but you have to actually now insert in order to understand how that asset is performing or your process is performing, that would be a case where you can start to look at applying machine learning or AI.
And you and I have talked about some of this before, Kevin. So I think probably the main difference is advanced controls is doing majority of this. But if you get some parameters in there or some extra data points that are outside of the model of the advanced controls, and you may have multiple data points that are part of that. I think where the more kind of artificial intelligence comes in is where, as Humera said, if the some of the inputs, some of the data, some of the circumstances go beyond what your model is. I think that may be where it changes, because artificial intelligence is more able to cope with this is a changing circumstance, whereas advanced controls, whilst dealing with multiple attributes and everything else, is still basically a model, and it's deciding based on that model.
A quick poll in the audience. Actually, who's been part of, or at your company, are they doing an ML or an AI pilot, at least a pilot? Anyone? Okay, not bad, like 15, 20%. Okay, how many have seen a PowerPoint on this and a pitch from a vendor? All right, don't need to raise your hand. I have a feeling it'll be close to 100.
Well, I'd ask the question, you asked the question of how many of the piloting. So of all those people that said, piloting, whatever else, how many have actually got machine learning or AI in production? Half a dozen? No, actually,
Just wondering if you volunteer, is it succeeding, or is it are people happy with the results, or is it kind of 50-50, or elaborate? I'd love to hear a real world example. It's like that's
Maria is coming your way.
Exactly.
Without going into too much proprietary detail, it's increased our inclusion inspection with our vision systems, our success rates with that, so that our display glass quality and throughput is improved.
Don't worry, we won't tell anybody that you told us.
Okay.
Great. Excellent. Any other questions? We're getting close to the end of the session here, so please, there we go.
Sorry, it's me again. I just wanted to add to the advanced process control. I did see that there are teams, I guess, researchers that are trying to couple, empirical methods with advanced process control. So using deep learning or genetic algorithms or something like that to tune a PID loop. So actually trying to marry those things together and get something out of it, which might be pretty interesting.
And I have one last quick question, too. So we did talk about the new business models and things like that. And usually in these sort of markets, there's a lot of excitement, there's some buying, and then we see the massive consolidation. Usually it's like when they run out of company names that almost resemble words, right? When you start getting these really strange ones, that's when the consolidation hits. When's that? I mean, are we looking 2-3 years from now, we're going to have this massive acquisition cycle, or is it going to be quicker, further out?
It's a great question, because we all see that coming, I think, in some segments of the market. I think right now there's a plethora of analytics firms, not necessarily AI and machine learning firms. So there are many, many companies running different forms of analytics, probably too many now. The funding that's gone on in these companies is astounding levels.
Oh, that's crazy, yeah.
But as we talked about earlier, many of them are starting to specialize industry by industry, and I think that's a more viable alternative for many of these. The AI companies are still few and far between. The investment required to develop your own AI, rather than just leveraging Google or one of the other platforms out there, is pretty substantial. Even developing something with Google's IP is still very substantial, and it's not reached the same level of kind of craziness that pure analytics has yet. So I think we still have a ways to run there.
You probably have an opinion on this, Humera. We'd love to.
Yes, I actually agree with Patrick on this, is that there are too many AI, and it was business intelligence that moved into AI. So we moved from data mining into analytics. AI, certainly everybody likes to call themselves AI, but when you actually start to kind of just peel off the layer, you don't have to peel off too many layers. You will be able to
change their name again to an AI company,
third
right?
time or fourth time would be a charm, probably. But anyways, I think that phase is not too far away. We're probably 3 to 5 years away from it, where you would see a lot of consolidation in the industry. But for the next few years, you would see the real emergence of AI. As you saw with in the crowd as well, there are lots of people that are actually experimenting. These experiments are now getting into real productions. So I think we've got a few years ahead of us where they will bubble up to the top, but there would be a lot of consolidation that needs to happen in the analytics space. It's far too crowded.
Yeah, excellent. Well, thank you.
I was just going to say, I think the one thing I'm looking forward to, because in the moment, if you look at most of these companies, they are taking algorithms and they're doing bespoke work for your artificial intelligence or machine learning approach. And most of it's bespoke. Most of it's kind of time and materials type work and things like that. I'm looking forward to some of this specialization will mean that we'll properly be off-the-shelf tools that you can pick up in different industries. And I think we're a little way away from that still. And I think when we start seeing that, that'll then lead to a very different view to the industry in terms of what companies are out there and that type of stuff.
But it goes back to that raw data issue. You can still have the tools, but if it's if it's garbage in, it's definitely going to be garbage out.
Yeah, and that's true of analytics as well. It's not just it's true of any computer system. You put garbage in, you get garbage out. Yeah.
Excellent. Well, thank you very much, and I wonder if you give our panelists a big round of applause. I'd greatly appreciate it. Give a big round for yourself too. Thanks, such a patient, inquisitive audience. Thank you very much.